This is Geometry, Section 6.2, Properties of Parallelograms. Today we started talking about parallelograms. So first of all, what is a parallelogram? A parallelogram is a quadrilateral, which we learned in the last section means a shape with four sides. So a quadrilateral with both pairs of sides parallel, meaning that the opposite sides, the ones across from each other, are parallel to each other. So this side right here is parallel to this side right here. This side is parallel to this side. And this symbol right here, this slanted rectangle looking thing, is our symbol that we use for parallelogram instead of writing out that word every time. So important theorems, we've got this symbol right here, the arrow, means if then. So this means if we have a parallelogram, then we can say that the opposite sides are not only parallel, but they're also congruent. So opposite sides, this side is congruent to this side, so we put one tick mark on each of those, and this side is congruent to this side. Another thing we can say, if we have a parallelogram, then opposite angles are also congruent. So this angle is congruent to this angle, we put one rainbow on each of those, this angle congruent to this angle. Next one is a little bit trickier. We say that all consecutive, I'll explain what that means in a second, all consecutive angles are supplementary. So consecutive, instead of opposite, which means across from, consecutive means right next to. So this angle and this angle are supplementary to each other. This angle and this angle are supplementary to each other. This angle and this angle, this angle, and this angle. So it means one right next to each other, just like consecutive numbers is one right after the other. So it means two angles that are next to each other, not across from each other. Those are supplementary, which again means adding up to 180 degrees. And last thing about parallelograms is that the diagonals, which means the lines that go from one corner to the opposite corner, so for example, segment SB would be called a diagonal. So the diagonals bisect, which means to cut in half. So the diagonals bisect each other. So each one of these, SB and GH, each of those is cutting the other one in half, which means that MG, this segment would be congruent to MH. And also SM would be congruent to MB. So this piece is congruent to this piece, and this piece is congruent to this piece. The diagonals cut each other in half. So, knowing what we just learned about parallelograms, we want to take this parallelogram over here and fill in all of these pieces here. So, first thing we said was that opposite sides are congruent to each other. So if this side right here is 9, that means this side right here is 9. If this side down here is 7, this side up top is 7. If this angle right here, angle S, is 65, that means the angle across from it or opposite from it is also 65 degrees. And then to find the other two angles, we know that P and R are the same thing as each other, but to find each one, we know that these two angles next to each other are supplementary, which means they add up to 180. So we take 180 degrees, subtract 65, and we get 115 for each of these angles right here. So if we fill in everything we just wrote in here, we've got QP is 7, PS is 9, angle P is 115, Q is 65, R is 115. Same thing down here, but now we have to label what we're given. So we're given that AD is 13, which means this side is also 13. We're given AB is 21, which means the bottom is also 21. AC, this entire piece, would be 28.6. So if we cut that in half, we get 14.3 for each of these two pieces of AC, because that's going to be cut in half. It's a diagonal. And then MD is 10, which means this other piece over here, MB, is also 10. So filling in everything, we've got DC is 21, CB is 13, AM, we already figured that out. We cut this number in half. We got 14.3, same thing for MC. We got 14.3. BD, this entire thing, since this piece was 10 and this piece is also 10, the entire thing would be 20. MB, that piece, that half would be 10, since this half is 10. Down here, we're given this parallelogram. It tells us that it's a parallelogram. So angle 1 would be congruent to what? Well, angle 1 is across from the parallelogram for angle 4. So angle 1 is congruent to angle 4 because they are opposite angles. And we know opposite angles are congruent in a parallelogram. Angle 2 is congruent to what, and angle 3 is congruent to what? So these are a little bit trickier. These are going back a while. We learned that since this is a parallelogram, and these two lines are parallel, this line we call a transversal, which means that this angle right here is congruent to this angle right here. Those are called alternate interior angles, because they're inside these parallel lines, but they're in the opposite side of this transversal. And we know that alternate interior angles are congruent. So we're going to say angle 2 congruent to angle 7, and angle 3 congruent to angle 6 for the same reason. Because now we've got these parallel lines, and this is still our transversal. 3 and 6 are in between these two lines, and they're on opposite sides of this transversal. So 2 congruent to 7, 3 congruent to 6, same reason for both, so I'll just write it over both of these, alternate interior angles. Given that this figure is a parallelogram, find all 9 missing angles. So we've got a bit of work to do here. First thing, let's start easy. We've got this angle in the middle here. This is a vertical angle, so if this is 55, this angle right here would also be 55. To find these two angles, which are also vertical from each other, we can take 180 minus 55, since these two angles right here add up to 180 and make a straight line, a linear pair. So if we do that, we get 125 here and 125 here, because these are vertical angles. Next, we have to deal with triangles. So if I start here, I've got 2 angles in this triangle. So to find the third angle in that triangle, I add up the 2 that I have, 80 and 55, and then I subtract whatever that number is from 180. When I do that, I get 45. Over here, to find this angle, we do the same thing. 125 plus 30. I add up the 2 angles that I have in this triangle, add those up, and then subtract that result from 180. When I do that, I get 25. So now we have to deal with alternate interior angles, which we just talked about on the last example. So if I go this way first, so these are parallel lines. This is a transversal. This angle is alternate interior from this angle right here. So this angle is 30. This angle, 25. If I look at this transversal, this angle is alternate interior from this angle. And if we look at this, everything is sort of symmetrical. So we've got a 25 and a 45 here. 25 is congruent to this. 45 is going to be congruent to this. Same thing here. I've got 30 here, 30 here, 80 here. 80 also goes here because of alternate interior angles. All right, each quadrilateral below is a parallelogram. Find the value of the variables. So now we're just adding in a little bit of algebra using the same properties we've just been talking about. Here, these opposite sides are congruent to each other since we have a parallelogram. So all we do, 12 equals 3b, divide by 3, b equals 4. Same thing here, opposite angles are congruent. So 72 equals 6a, divide by 6, a equals 12. So a is 12, b is 4. Next one, we've got 4y and 5x are opposite from each other, which means they're congruent. But I have an x and a y, so I have to figure out a different way to solve for one of those variables before I can solve for the other one. Luckily, we have this down here. However, this angle, this 3x plus 20, is not congruent to the 5x and the 4y. It is supplementary to both of them. So instead of setting them equal to each other, we take 5x plus 3x plus 20 and set that all equal to 180, since these are supplementary to each other. So now we combine our x's. 5x and 3x is 8x. We subtract our 20. we get 8x equals 160, divide by 8, and we get x equals 20. Now that we know x equals 20, we can plug that in for this angle right here. So 5 times 20 is 100, which means this angle right here is also 100 since it's opposite from this angle. So if 4y equals 100, we divide by 4 and y has to equal 25. Next one, similar situation. We've got these two angles opposite from each other, but we have two different variables. So instead, we have to take one of these pairs, add them up, and set them equal to 180. So if I take 2k plus 120, all of that equals 180. I subtract the 120. 2k equals 60. Divide by 2. K equals 30. So k equals 30. And if I plug that back in here, 2 times 30 is 60, which means this angle also equals 60 degrees. So 3h, 60. 3h equals 60. When I divide by 3, I get h equals 20. Here on letter D, we're dealing with diagonals. So we talked about how the diagonals bisect each other, which means they cut each other in half. That means that this half of this diagonal is equal to this half of this diagonal, because this one is cut in half right here. So all I do for this is take 2x plus 6 equals 3x, set those two pieces equal to each other, and solve for the variable. So I subtract 2x, 6 is left over here, 3x minus 2x is just x, so x equals 6. Now I have to figure out what AB is, this entire piece right here. Well, if this is x, we just figured out x is 6. That means this other half has to be 6, which means this entire segment from A all the way to B would be 6 plus 6, or 12.